So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to learn the lecture about GIS data file management. Okay, so this will be the topic for today. So we'll be discussing or we'll be learning about the GIS data file management. So in the previous lectures we have already learned about the database management, types of databases, what are the files, how the data is stored. Now in this today's lecture we'll be learning about the different file management, how the file is managed. So we are going to learn this all today. So let us start with the lecture today. So in this lecture, we'll be having this different contents like data organization, file naming conventions, data formats, data storage, data backup and recovery, data quality and validation, GIS data file formats, vector data file formats, Imagine, GeoTIFF, file geodatabase. So this all we are going to discuss today, and we are going to understand what type of file management, how the GIS will be managed by this all kinds of management. So DBMS is one of the main source how it is the data is all saved in that system and it is managed. So there are different key aspects of for effective GIS data file management. So to manage a file, we have to organize the data. So what are the data we have to organize? First of all, data organization. In data organization, we have folder structure. So what are the different types of folder? What are the different types of structures we have in GIS to be managed? So create a logical, consistent folder structure. To create a folder, under the folder we have subfolders to be created. Organize files by project, data type or other relevant categories, and it will use the clear descriptive names for the folders and file. So it will use the descriptive names. For example, it has a folder here. So folder will be having, for example, we name this folder as, let us say, water body. Okay, so water body will be the folder, main folder. Under this we have in subfolders. Subfolder we have like, we have the shape files here. Okay, shape files. Under the shape files we have the coverages. So different folders will be creating in, and all the data will be organized in a folder structure. So use descriptive names for the folder and files. And workspace folders are simply file folders on the disk that hold numerous file and personal geodatabases. So this is type of the folders in GIS will be created. So the types of the folders will be created is GIS. For example, this is the file folder 1. So under this we have GIS 101 and GeoNIS. Under this we have original data, results, MXDs, final data, output maps and documentation. So under this we'll be having this .gdb, and we have results here, we have MXD here. So these are all the data will be saved in this file folders and which will be organized properly in the GIS database. Now file naming conventions. So in file management there are different folders will be having different files with the different names, where the files will be named properly. Use consistent descriptive naming conventions for the files and the layers. It includes the project names, data types and date to make file easily identifiable. So it includes the project names, the data types, the date to make the files easily identifiable, which will help us to search the folder. If you just try to search a folder, if you type with a file name and with the file data type, or which will be easy to just search get the results easily, immediately will be able to get the data from the system. So it includes the metadata for each data sets also, and as such as a source, data, date of creation, coordinate system and processing steps. So it includes the metadata. What is metadata? If you remember, we have already discussed many times. Metadata is data about the data. So it will help us to give you the data information and the source, such as source, date, creation, coordinate system and the processing steps in the system. Now we have a data format. So what are the different data formats where we can just store the information, the files will be managed. So like we have a GIS data file management, like vector data, we have common formats includes shape files, GeoJSON and KML, KMZ file, the geodatabases in the vector data formats. Whereas in the raster data formats, you have common formats includes In raster, we have GeoTIFF, we have JPEG, PNG, and grids. So these are all the formats of the data formats of the vector and raster. So when you talk about the vector data formats, you have a shapefile. .shp is the data. So total file is managed. File is managed by .shp or shapefiles. Like KML, KMZ, and the file geo databases. Raster data common formats include GeoTIFF, JPEG, PNG, and grids. So these all types of raster data formats are included in this raster data common file management system. Now metadata, which includes the data like .xml and that describes the content quality, condition, and other characteristics of the data. So now data storage. Data storage has a local storage, like use the structured folders on local or network drives, and it has a cloud storage, utilizes cloud services. Example, AWS S3, Google Cloud Storage for large data sets and the collaboration. So this data will be stored in this kind of the file will be managed in the data storage, and databases use the spatial databases for the efficient data management and the querying. So all the data which is stored in this databases will help us to manage the files in the spatial databases and efficiently data managed and through the querying process. And data backup and recovery. So different data backup and recovery, if you see, regularly backup the data multiple locations to prevent the data loss. So regularly, if you back up the data and if you have a multiple locations to prevent the data losses, it implements a version control system to track the changes and revert the previous versions if necessary. So if you have this regularly data backup and if you have a multiple locations, it can help you to prevent the data losses from the system or the database or from the computer system. And it will implement a version control system to track the changes and revert to the previous versions if necessary. So data backup and recovery are critical components of GIS. They are the critical components of GIS. So data backup and recovery is the critical component of GIS. Data management strategy to ensure the data integrity, continuity of the operations, resilience against the data loss. So these are the main we can say, if you talk about the components of GIS, we have a hardware and a software component, but in terms of this file management, the GIS is having two main critical components, that is data backup and data recovery. So data management strategy will ensure the data integrity and the continuity of the operations and resilience against the data loss. So if the data file management is properly managed, all the databases are properly stored in a folder files, then the resilience of the data will remain proper. Otherwise, there is a chance of the data loss whenever the data is misplaced from one place to another. Now, data storage, when you're talking about the data quality and validation. What is data quality and validation? So data quality, first of all, the accuracy is the main part of the data quality. If the data is having more accurate information, then the quality remains proper, and perform the regular data validation checks to ensure accuracy and consistency. Use GIS software tools for data cleaning, error detection, and correction. So it will use the GIS software tools for data cleaning. So if the data quality and validation is proper, then it will be helping the GIS software tools for data cleaning and error detection. It will help us to detect the errors and it will help us to do the corrections in the GIS software. So data quality and validation are the critical aspects in the process of the system. So data quality and validation are the critical aspects. So quality and validation also are the critical aspects which will help to process the system, ensuring that the data is accurate, reliable, and suitable for the indeed purpose. Data is accurate, reliable, and that is what resilience. The data should be, if the data quality is accurate and the data quality is proper, then the resilience and the reliable suitability will be intended in its purpose. Now, GIS file data formats. Now we have GIS data file formats. So what are the data formats we have here? So in GIS world, you will encounter many different GIS file formats. Some file formats are unique to specific GIS applications, others are universal. So in the GIS world, if you see, you will encounter many different GIS file formats. So there are different formats where we can just encounter, and some file formats are unique to specific GIS applications and others are universal. For this course, we will focus on the subset and the spatial data file formats. Now, when you talk about this shapefiles for vector, now here shapefile is for the vector data. Imagine geotiff files for the raster. So when you talk about data formats, if you are using .shp like shapefile, then the shapefile is, what is the shapefile? Shapefile is the vector data format. So all the data will be stored in the vector data formats, and the imagine and geotiff files for the raster geo databases and the geo packages for both the vector and raster. Now, Geographic Information System GIS data file management involves the organizing, storing, and maintaining the spatial data and associated with an associated attributes. So it will help us to organize the data, it will help us to store the data, it will help us to maintain the data, spatial data, which will be associated to the attributes. Now, GIS data file management involves the organization, storage, and manipulation. So it will help us to organize the file data, and it will help us to organize, it will help us to store and manipulate the data. Spatial data to support analysis, visualization, and the decision making will be more easier when the file management is properly done. Now, when you talk about the vector data file formats, so as I told in the previous slide, vector data file formats, the data will be saved in the form of shapefile. So a shapefile is a file-based data format native to ArcView 3.x software, as much older version. So ArcView, we have a older version. Now the newer version we have is ArcMap. Okay, so conceptually, a shapefile is a feature class. It stores a collection of features that have a same geometry type. So shapefile we have discussed many times, like point, line, polygon. So these three are called as the shapefiles. Okay, so these are the shapefiles which are managed by the GIS file management, and all the vector information along with the shape, that is spatial, along with the spatial, non-spatial information is saved in the system. So this is called as shapefiles, and conceptually shapefile is a feature class. It's a feature class. It stores a collection of features and they have some geometry type. Like geometry type means it has a point geometry, it has a line geometry, it has a polygon geometry. So point, line, and polygon, the same attribute and a common spatial extent. Now, despite what its name may imply, a single shapefile is actually composed of at least 3 files, as they may as many as 8. So initially, actually, it is composed of 3 files when you talk about shapefiles. So first of all, that shapefile will be .shp first of all. Now, if you see here, .shp and .shx and .dbf. .shx and .dbf. So these 3 files will be initially created. Once you create a shapefile, it will be initially created and imply a single shapefile. So it is actually composed of at least 3 files and as many as 8 files. So first 3 files will be created. Later on, the rest of the files will be added to the shapefile. So each file that makes up the shapefile has a common file name but different extension type. So it has a common file name but it has a different extension type. So the list of files that define a shapefile are shown in the following table. In the coming slide, I'll show you. So each shapefile has a specific role in defining the shapefile. Now, if you see the extension files of shapefile, so once you create a point, so this is the point is created. So this is the point is created. So the point will be having this all files. Okay, these all files. Like first of all, .shp. It will be having .shx, it will be having .dbf. So these are the first 3 files. First 3 files created. Okay, first 3 files created. Later on, these all files are added to it. Okay, so these 3 files are created. Now, first .dbf, if we talk about .shp, what is .shp? It's a feature geometry. .shp is the feature geometry. So it will show you the shape, either point, either line or polygon. So this feature geometry will be there, either point, either line, either polygon. Later, based on the shape, this all files will be created. So once I create a shapefile as a line, so this is the line. So immediately what will be created? The file will be created as .shp. Okay. So again, after .shp, the .dbf, it will give you the, so what is the feature geometry here? This is the feature geometry. This is the feature geometry. Now, next it will be created as .dbf. What is dbf? dbf is the file information where the attribute information is added. So now this shape is a spatial one. It's a spatial. Now .dbf, once we create .dbf, so this .dbf will be as .dbf. So this is the attribute information. .dbf is the attribute information. So it will give you the database file and later shx. So it has a one more index called as feature geometry index. Feature geometry index. So .shx, it will give you a feature geometry index. Okay, so it will give you the information about this index of the attribute information or the geometry index. It will give the information .shx. Then later, while starting, once you start this editing, suppose this is the line and we have started editing like one click here, 2, 3. So these are all editing parts, like nodes will be creating. So as we create these nodes, later after saving, once you save, so what will happen? These files will be added to it. What is that? AIH is attribute index, and we have AIN, that is attribute index again. PRJ, coordinate system information. This coordinate system information will be added later when the requirement, when we are going to assign the coordinate system to the vector data. So this coordinate system information will be added. Then .sbn. So .sbn is spatial index file will be added to it. Then later .sbx. So spatial index file will be added to it. So we have this total total 8 file formats or extensions will be added to a single shapefile. So the single shapefile can be point, can be line, can be polygon. So these 3 shapefiles, we will see the extension files will be added to these shapefiles. Okay. Now file geodatabase. What is file geodatabase? Geodatabase we have already learned in the previous lectures. So database are having different types of databases which will have to save the entire spatial and non-spatial information to the system. So a file geodatabase is a relational database storage format. It's a far more complex data structure than the shapefile and consists of a .gdb folder housing dozens of files. So .gdb, so this is the database which contains dozens of files. Like if we are talking about the database, it has an attribute table, feature class, cartographic representation, annotation, dimension, relationship class, raster dataset, raster catalog, topology, geometric network, network dataset, terrain, locator, survey dataset, toolbox. So these all are the different types of files which consist in the folder, and they are having the dozens of files in the folder which will help the database to store this all information in the system. So now if you see here in this multi-user GDB, we have RDBMS, enterprise GDB, work group GDB, and desktop GDB. So this all information is saved in the DBMS. Okay. Now its complexity renders it more versatile, allowing it to store the multiple feature classes and enabling the topological definitions. It enables the topological definitions, and it has an example. Like if you talk about the contents of geodatabase, is shown in the following figure. So we have different these contents in the geodatabase. What are the contents here? If you see, we have geodatabase. For example, flood. Flood is the one database is created. So immediately the extension file of this will be GDB. So under this the GDB we have this is the coverage it is created, coverage. So under this coverage we have two shape files here we can see, that is land use polygon and other one is parcel. So under the flood will be the database. Under the database we have a coverage called as municipal, and this is a feature dataset. Under this we have shape files called as, these two are the shape files which are called as land use polygon and parcels. Now here you can see feature classes. When we talk about feature classes, so in feature classes directly we will see the shape files. So we have these three shape files: city limits, county boundary and demographics. So these three we have, and place names we have, like city limits, country, these are the shapes we have. So these are all three are polygons here again, polygons. So in this polygons we have this types of shapes for the city limits, for the country boundary or demographics. Based like this we have the different types of shape files if required. So this is one example given for the feature classes. So when you talk about again non-spatial table will tell you about the information about the school buildings, or information about a building, information about the attribute data, or any kind of geodatabase, any kind of attributes, non-spatial information which is added to the information is added to the table. So that all comes under this non-spatial table. So these types of example we can see geodatabase in the software. So in geodatabase you will see the immediate geodatabase file will be created as GDB. Under that we have a coverage, we call it as feature dataset, that will be as a this type of shape we can see, municipal or any information if you want to keep forest, that all. So under that we can just create the shape files. That shape files will be as land use polygon, parcels. So like this we have a feature classes for city limits, country boundary or demographics, or forest boundary or water body. Based on the requirement these features are created further. Now raster data file formats. So what are the raster data file formats? What is a raster data? Basically, if you remember, we have discussed many times in the previous lectures. First of all, raster is related to the pixels. Okay, it is related to the pixels like this. This is a raster data. So in the raster data, how the files are saved, the data is saved in the form of grid cells, in the form of pixels, in the form of pixel numbers, in the form of DN numbers. So there are different formats when you talk about the JPEG file, if you talk about the TIFF files, all the scanned data, all the data which is in the digital format, all the images which is in the digital format, that all data is called as the raster data file formats. So rasters are in the part of defined by the pixel depth. Pixel depth defines the range of distinct values and the raster can store. For example, a 1-bit raster can only store two distinct values, that is 0 and 1. So 0 and 1 will be stored here, like I'll show you in the bigger one. So if you have this kind of rasters, so either zeros here, either 1. Okay, so that means that 0 is absent. Okay, 1 is present. So here 1 is available, 0 is absent. So that kind of particular feature is not available. So data quality and validations are the critical aspects of any data-driven process or system, ensuring that the data used is accurate, reliable, suitable for its intended purpose. Now, raster data formats, if you see the raster data formats, it is saved as 1-bit binary, 2 bits, 4 bits, 8 bits, 16 bits. So in different levels, it will be saved based on the type of the data. So either in the binary 1-bit data, 2-bit data, 4-bit data, 14 bits data. So all will be saved in the form of a grid format in the raster formats. Now imagine. So what is imagine is image. Basically, it's a image, and its file extension is its file extension is .img. Okay, .img, because all the files will be saved in this .img. So imagine file format was originally created by an image processing software company called ADAS. So imagine a file formats, this was created originally by the ADAS. ADAS is a software for image processing, for processing an image, like kind of making it bright, contrast, increasing the value of radiometric resolution, and any kinds of corrections if you want to do. We can do this corrections in the ADAS software. So imagine file format. This format was given by this ADAS software. So the file format consists of a single .img file. As I said, when the file format, when you save a raster image which will be saved in .img. Okay, so the file extension will be in .img. This is a simpler file format that a vector than the vector shapefile. So vector shapefile has .shp, whereas when you talk about this raster, we have file formats like .img, which is compatible with this software. So easily we can just find out the resolution will be properly maintained once the file converted into .img. So the TIFF files, whichever we have, the scanned files which is in the TIFF format, which is in the JPEG format, that can be converted to .img with the help of this ADAS software by conversion process. So this is a simpler file format that vector shapefile than a vector shapefile is have. So it is sometimes accompanied by an .xml file, which is usually stores metadata information about the raster layer. Now GeoTIFF. So GeoTIFF is also, it's a popular public domain raster data. So most of the files, if you see in the GIS, will be in the format of the GeoTIFF format. So all the data which is scanned through scanning or any scanners, we get this information, all the paper format data. Once you scan this data, that will be converted into GeoTIFF format. So GeoTIFF format is a format which is compatible with the ADAS software. So once you want to use this GeoTIFF format directly, it can be used, or else this format, GeoTIFF format, can be directly converted to .img format. Okay, so it is the maximum portability and platform independence is important. This file formats may be a good choice. So it's a domain, it's a popular public domain. Wherever you see, most of the files will be in this format itself. In the GIS, most of the files will be in the GeoTIFF format. The GeoTIFF format, short for geospatial tagged image file format, is a widely used format for storing the georeferenced data. So once if you want to georeference the data, that georeference data will be stored in this GeoTIFF format only. So georeference data means once you assign the coordinates to the file, suppose we have a topo sheet here. So this topo sheet, once you assign a point to this sheets, okay, assign the points to this sheets. So once you assign the latitude and longitude, okay, longitude. So what will happen, these files will be georeferenced again. So once the files are georeferenced, we have this points which are properly run in the ADAS software or GIS software to assign these coordinates to the file format. So once you assign these coordinates, the data will be georeferenced, and later it can be saved as a georeferenced raster data. So it extends the capabilities of the TIFF standard by adding the geographic metadata and georeferencing information. So most of the data, it is in the GeoTIFF format, or else later it can be saved even in the TIFF format. If it is that, later it can be converted to the Imagine format also. Now file geodatabase. So file geodatabase, we know already, like a raster file can also be stored in the file geodatabase alongside the vector files. So how the vector files are saved in the geodatabase. Same the way the raster files can also be saved in the geodatabase. Now geodatabases have a benefit of defining the image mosaic structures. This all allowing the users to create a stitched images. For example, what is a mosaic? So mosaic is like stitching the images. For example, we have a different topo sheet here, topo sheet 1, or else I'll show you what are the. So this is photo number 1, 2, 3, 4. So we have 1 image, 2 image, 3 image, 4 image. So these 3, 4 images are separately here. We gather it separately like this. So later, if you want to join this together, joining this together, what we need to do is we need to stitch the images from multiple images. So this stitching is called as stitch the images. We call it as mosaic. Okay, we call it as mosaic. So mosaic means assigning the coordinates. We have separate 4 images. So this separate 4 images, we have to align it properly, we have to stitch it properly, and then we can get the output of that. So to stitch these images, what we have to do is separately, individually, we have to assign the coordinates to that each photo or each map, right? So individually, what we are going to do is we are going to assign the points here. For example, we have assigned point 1, 2, 3, 4. And point 1, 2, 3, 4, point 1, 2, 3, 4. Like this, 4 points we have assigned, and we have assigned the latitude and longitude. Okay, longitude. So once you assign the latitude and longitude, what will happen? Then later run the processing. Run processing. So once you run the processing, what will happen? These all the 4 images will be aligned together and it will fit to its location. So here it has fit to its location. Now what happens? These 4 separate images will be stitched together. So this is called as mosaicing. Means just assigning the coordinates, aligning it together, and finally run the georeferencing process. And later we can just run the mosaic process, where you can just get the stitch images from the multiple image files stored in the geodatabase. So these all files should be stored in the geodatabase, then only it is possible. So a file geodatabase is proprietary geospatial data storage format where the data is saved. So these all files which are saved in the geodatabase can help us to make the file properly managed. Like it can help us to, wherever it is saved in the folders, it can be properly managed. Once the database will be saved, all the files will be saved in the database, which will help us to mosaic, which will help us to stitch the images, and later we can do any, if analysis part is required, we can do with this kind of data. So also processing is very large raster files and can be computationally more efficient when stored in the file geodatabase, and as opposed to the imagine or geotiff file format. So file geodatabases stores the data and collection of files in the folder or disk rather than within the single large file like traditional geodatabase or traditional database formats. Now it consists of the various file types, including files for spatial data storage, dot GD table, or spatial indexes like attribute indexes, dot GDB index, and metadata in GDB item info. So these are the file formats where the geodatabase data is the data will be stored in the geodatabase, and the collection of files in the folders on the disk or rather within a single large file that traditionally in the database are stored. Okay, so this is about the geodatabase, which will help the users to get these files together, and if GIS will manage all this file properly. So whenever the files are required, it will be easily searched with the folders, easily aligned with the folders, and easily we can just create the mosaic process or stitched images we can do, and later we can use this data for the any other requirement, whatever is required. So this processing is done in the database management system. So file management is very much helpful to store the information. So once it is stored in properly, accurately it is stored in the database, then later these files will be helpful for the further processing whenever it is required. These are the different data file management, different formats like vector data format we have, raster data format we have ADAS software where these all files are managed, or GIS software where these all files are managed. So based on the requirement, the data will be saved in the database, and the data query we can do, and finally we can do the processing with the help of these all kinds of data. So this was about the GIS data file management, and these are the few references you can just go through for getting the more information. So MNG Reddy Remote Sensing and GIS from GIS publication, you can just go through this textbook for getting the more information about it. And later you can just go through this link to find out the more content about this data management, file management of GIS. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.